Welcome back to our little data journey where we built a database that Bloomberg would be jealous of. In the last episode, we downloaded index holdings for the S&P 500 and the Russell 1000 and stored them into a database. If you missed that episode, feel free to go back to it. We're gonna link it on top right now. Today we're gonna expand on it and we're gonna download prices, financials and company information for those companies. Why is this important? As we discussed earlier, manual copying can be very error prone and slow at times. You don't want to go in and copy the financials for all of the 500 or even 1000 companies. There's also API limits if you use Bloomberg or other data vendors that you have to either pay for or that just don't allow you to pay to pull so many data points at once. And it's just a very repetitive work if you have to do it over and over again. We're gonna use yfinance in this tutorial. Yfinance is a Python package that allows us to easily automate the data pulling of all the financials that we wanna look at. We're gonna pull those financials and centralize them in our SQL database that we started in the last video. Why is that important? First of all, we want to build a comprehensive coverage of all the prices and fundamentals and company information for the companies in our indices so that we can build backtests and other explanations and other analysis later on. Secondly, it is a very affordable solution. In fact, it is free. yfinance offers a lot of data that you can pull via their API. And of course, it is very time efficient. You don't have to copy the data yourself. You just let Python do the work for you. So let's jump in. Before we start jumping into the code, let us look at the Yahoo Finance website first. I opened it up for the company Apple with the ticker AAPL. Right on the starting side, you see a little summary with like prices and news. And we can easily just go to historical data and it gives us the open, high, low, close over time for Apple. If we go to profile, for example, we can see the key executives like Tim Cook. We see information such as the address and the telephone number. And we can also go to financials and we see income statement, balance sheet and cash flow information for annual and quarterly horizons. So we could easily pull the revenues, profits, and so on. Also, there's a holders tab where we can see what the insider percentage holding is, as well as the percentage of held by institutions. We're gonna pull all of that data in a second using Python and the yfinance package. Let us once again start by importing the necessary packages. We're gonna use pandas here, and as mentioned before, the yfinance package. We also install the SQLite package that we used last time, so we can pull our data that we already stored in the database. We're gonna start by linking to our database. If you remember from the last video, that is the exact same path that we used to store the index holdings for the S&P 500. So let me import our packages and link to the database. Now we just need to connect to our SQLite database, similar to what we did last time, and we pull all the holdings for the S&P 500. So let me run that cell. As a last step, we need to clean up the data a little bit here. For Berkshire Hathaway and BFB, we need to add dashes so that yfinance later knows what company we're talking about. So if we run this code and we're gonna look at df, we now see the 503 holdings for the S&P 500 on 131. And again, we start by NVIDIA being 7.8%. Now we are finally ready to use Yahoo Finance to pull all the information that we want out of Yahoo Finance. As a first step, we need to create a tickers object that is specific to Yahoo Finance. So we use Yahoo Finance.tickers and we pass in a list of all the companies in our index. So you're gonna use the df that we created on top and we use df.tickers, and we use everything that is unique in those tickers. That creates a tickers object, and if you look at tickers, we can now see it's a Yahoo Finance tickers object on Nvidia, Apple, Microsoft, and so on. Let's start by pulling company information now. We start on just pulling for one company, and then I will show you guys how to iterate over all companies in our index. So let's just start by doing all of this for Apple. To start using Yahoo Finance, we need to create an actual Apple object, and we can just reference the tickers that we have on top. We can look at all the tickers in our ticker object, and we slice it to use Apple. Because if you now look at objects, now we have a single Yahoo Finance ticker object with Apple. As the next step, and already almost the last step, we can create an info dictionary by using object.info. If you look at info, now we have a nice dictionary that shows us, for example, address 1 Apple Parkway, city Cupertino. Very easy to use, and that's already almost our last step here. All we really have to do is slice out the officers. If we say officers, and that's the executive that we looked up earlier on the Yahoo Finance website. So if we say officers, we say info.get, and we want to pull the company officers. And if they're not there, we just pull an empty list. And I will show you guys why we need to do this. It's exactly because it's stored in this format. It is a list of all the executives stored as dictionaries again. We can now see, for example, Tim Cook as their CEO. And we can even see the total pay that Tim Cook got paid last year. We now want to remove those officers from our info temp or from our info dictionary. So we say if officers, we want to delete info on company officers. And now if you look at info, there shouldn't be any officers anymore. Now we're already at the point where we can create a data frame so we can store it into our own SQL database. So we can create an info temp data frame, and we just call it info temp equals pd.dataframe, and we list this and say we want info. Easy enough. And if we look at info temp now, we see that we have a nice data frame with address, city, state, zip code, and so on. And we want to do the same for the officers. We say officer temp equals pd.dataframe, and the officer are already a list, so we can just pass it in without the list. And we look at officer temp, and we see Tim Cook with his total payment here. Now let's just clean up the data a little bit before we store it in our data frame. So we do something similar that we did last time. So info temp on ticker being T, so that is our Apple. And we also want info temp on date being date.today. And I just copy that over. We want to do the same for the officers. I just run that cell. Next, let's clean up the column names a little bit again. I'm just gonna copy that over. It's very similar to what we did in the last video. First of all, this is now officer temp. First of all, we're gonna make all column names uppercase. And second, we're gonna put the date and the ticker that we just created at the beginning of our database. So if I run that one and we look at info temp, we now have nice formatted column names with date, ticker, address, and so on. As a last step, now we did it for one company. We want to do the same for every company in the S&P 500. we can basically just take the same script and iterate over all the companies. I have that prepared here already. So we can see all I'm doing is basically just iterating over all the objects in the tickers.tickers, but it is the exact same code on what we did on top. So if I run that code, it might take a while to run, so I'm gonna fast forward here until the code is done. Perfect. We're now ready to use the all info data frame. And we're gonna look at it and we see all the 503 companies now have company information here. So all we have to do is store that data into our database from last video. So similar to last time, we use the SQLite package and we connect in the same way that we say database equals database log and con.close. And now all we have to do is write our all info to SQL. And we call it company info. And we give it the same connection. And if it exists, we replace it. If you run this on a daily basis, you don't want to replace, you want to append here. But for us, it's the first time running it, so we are totally fine just replacing it. And we don't want to write the index. We already closed the connection, we ran it, and now it's stored in our database. So let me copy this over and this also. Now if we want to look on what we stored, we can again run a SQL query. And I'm just going to copy that over. We want to run the company information for Apple, Microsoft, and Tesla. So if I run that and we're gonna look at info.df, we can now see we got Apple, Microsoft, and Tesla stored from our own database. Before we jump into pulling the price data for all of our companies, I want to show you guys a little visualization on the data that you can easily create yourself. As you saw before, we pulled all the addresses for the companies with the state and country information. So we're now able to plot their headquarter location on a map of the US. So if we scroll over it, we see there's a couple of companies that are headquartered in the San Francisco area. There's some companies headquartered down here in the LA area. And there's, of course, a lot of companies on the East Coast, for example, in New York City or down here in Miami, Florida. We are now ready to run the same Yahoo Finance script on company prices. You will see it is very familiar to you already, as it is very, very similar to what we just did for the company prices. Let's start on our one Apple example again, and you already know the syntax. We create our object by using tickers.tickers and slice for AAPL. All we have to do is call that object again, similar to what we did for the prices, for the information earlier. So we see that we just need to use object.history this time. And let's just give it a start date. Our start date here being, let's say, 2020, January 1st. And we don't want to auto adjust. If we look at prices, we can already see we got open, high, low, close, adjusted close, volume, dividends, and stock splits for Apple over time. We can see that the date is stored as the index. We don't want to do that, so we just say prices equals prices dot reset index, and now the date is a column itself. Lastly, we do something that we did in all the other cases. We say prices on ticker equals our Apple ticker. And we do the same, prices dot columns equals, and then we do call dot upper for call in prices dot columns, just to clean up our column headers. If you look at prices now, you can see we have our date column, we have our ticker column, and all the other columns that we had before. Similar to what we did for the infos, we now need to iterate over all our tickers. So it's the same script again, just iterating over all the tickers. So I'm gonna start running it and fast forward to the end again. Okay, we now see that we're in the last couple of companies. So I'm already preparing the code for us to write it to the database. As we did that a couple of times already, I'm just connecting to the database, I'm closing the database, and I just use the toSQL function, creating a prices data table in our finance database. And once again, we can query that database to check if we actually wrote it. And we can look at all the data that we stored for Apple by looking at prices.df. And we see we have our date, open, high, low, close, adjusted, and so on. So all the columns that we had before. Once again, we can visualize the data a little bit. I'm decided to go with Apple in my example again, so we can see the Apple candlestick chart. If I zoom in, we can see the candlestick a little further. Maybe we go on a 6-month basis. And we can also see the correlations of Apple to McDonald's, General Electric, Disney, and Microsoft. And we plotted a box plot of the return distribution of those companies. So we can see that General Electric here has a little bit of a bigger box compared to Apple that is fairly centered around 0. Whereas Microsoft had the biggest outlier with almost a 10% negative return on one day. The last thing we will look into is pulling company financials. As you know the syntax by now, I'm gonna just copy it over. We are creating the same Apple object again. And now we, instead of the company information or the history, we pull object.financials. We're gonna create the same financials temp again. We reset the index and we add our date and ticker functions. We again make our columns uppercase, and we reorder the columns so that ticker and date are at the beginning. If I run the script and we look at financial temp, we can now see that we pulled the last 4 years of Apple fundamentals, or even 5 years, and we have a lot of columns, for example, tax effect of unusual items. We have some net income, we have some EBITDA information here. Once again, we want to run that for all companies, obviously. So once again, it's just the same script iterating over every company. Instead of financials, I'm gonna pull the financials quarterly here. Sorry, it's the other way around. It is actually quarterly financials. And we run that script. So you can see, similar to what we saw on the website earlier, that there's always a annual version and the quarterly version, and the annual version is just the data item itself, whereas the quarterly version is indexed by quarterly underscore. We're gonna fast forward again to the end of the data pull. Okay, we're almost done with pulling our financial data. And as you know by now, you now need to connect back to your database and write that data to your database. I'm gonna skip that for now, and we're just gonna look at some visuals of that data. Once again, we went with Apple here, and on the top and a couple of competitors, the same that we looked at before, Disney, General Electric, McDonald's, and Microsoft. And on the top-hand plot, we just plotted the EBIT of those companies. So you can see that Apple, by a big margin, had the biggest EBIT out of those companies, followed by Microsoft. On the bottom here, we see a little God chart, seeing that Apple's actual last EBIT was behind its mean by like 0.8 billion. We can also see the composition of Apple's total revenue in a waterfall chart. Where we start on total revenue, we deduct the cost of revenue, operating expenses, tax provisions, and we end up at the net revenue. As a last little thing, very similar to what we did for the financials, you can pull balance sheet item by using .balance sheet. You can pull income statements by using .income statement, and other data items that you can just reference to pull the gf.ticker item. Once again, we covered a lot of ground here. You're now able to pull company prices, fundamentals, and company information and store them into your own database. That enables you to run backtests on financial data and your pricing data. For example, using momentum strategies or value strategies. We will cover all those use cases in future videos. For now, start playing around with all the data that you stored and let us know how that works out. Thank you for watching the video.